Hello everyone. In this lesson, we're going to learn about Ohm's law. So Ohm's law is the relationship of current and voltage inside a circuit. So let's say you have two materials, one being a good conductor and one is a sort of poor and average conductor. So when we say something is a good conductor, we want it to be not that resistive, so it must have low resistance. When we say something is average or such a poor conductor, we say that it has let me say bad, so let's just say poor resistance, or no, this should be high resistance. So let's take the case first for a good conductor, so with low resistance. So let's see the relationship of an object with a low resistance. Let's say we have an unknown material here and we put a battery through it. So this battery drives a current in this conductor. So this is our conductor, and we know that this conductor has a low resistance. So if it has low resistance, let's say our battery can be adjusted with different values of voltages, and we can measure the currents inside this good conductor. So for example, in 0 volts first, we don't have any current. So our plot in the y-axis would be 0, 0. In 1 volts, applying 1 volts in the battery, we have, say, 1 ampere. In 2 volts, 3 volts, and so on, 4 volts, we see that current is increasing linearly with respect to the voltage applied. So we can derive a relationship between current and voltage with proportionality. So we can say that we can say that this current I is directly proportional to the voltage applied V. And we know that this object has low resistance. So if we want something to have low resistance and to classify it as a good conductor, we should put here the relationship between I and V to be 1 over R. And actually, this 1 over R is the slope of this line. So if you divide the change in current over the change in voltage, you would get the value 1 over R. So what this 1 over R means is that if R is big, then this whole term is small. 1 over R is small. And if R is very small, this term 1 over R is big. So in our case, if we say that this good conductor has low resistance, we want that R is small so that 1 over R is big. So this means that it scales up the voltage. This driving current in this circuit scales up the is directly proportional to the voltage by a big amount. So there will be a big current running through this circuit if the resistance is small. So that is the case for a good conductor. So a good conductor should have low resistance, while a average or a poor conductor will have high resistance. So if R is big, then 1 over R is small. So it means that if we apply a voltage here and we measure the current and we replace this good conductor with the poor conductor, this current will be small. So that relationship is given in Ohm's law. So as we stated earlier, current is directly proportional to the voltage applied. V equals IR. So in the later videos, we will be solving circuit problems using Ohm's law. And let me put this is, of course, we didn't mention earlier, this is the resistance, this is the current, and this is voltage. So in the next videos, we will be using Ohm's law to solve currents, voltages, and resistances in different circuits.